Okay everyone, this is the second video for the natural logarithmic function where we are going to focus on the differentiation of natural log. So let us recall the formula that we have just now. So before we go for the differentiation here, we are going to use the formula of d over dx of ln u equals to 1 over u multiplied by du over dx. Okay, this is the formula that we used in our first video just now. Okay, let's recall the first example. Let's say here we try to deal with the third example number 3 here, where we have y equals to ln of 3x power of 5 plus with 2, and then you have another power here which is, let's say, 10. Okay, so actually in order for you to answer this kind of question, we have two methods, but here let us try to stick with one method here, which is we are going to utilize this formula again. So based on the example here, we have ln u, and we are supposed to get here also ln, and all of this value that I put into bracket here is actually the value of your u. This is the value of u. So you can say that the value of u here is equals to 3x to the power of 5 plus 2, and it is supposed to the power of 10 there. Okay, please also do include the value of 10 there, because based on the formula here, all the value that is next to the symbol of ln supposed to be the value of your u. So we take all. So here, in order for us to differentiate the function, where we are supposed to get here du dx, where we can replace the value here after this. So in this case, we are going to use the chain rule formula, where we are supposed to get here the value supposed to be 10 multiplied by 3x to the power of 2 plus 2, and then the value here is supposed to be 9. Then don't forget to multiply it with the differentiation of this value. So if you try to differentiate that one, so I think this is supposed to be 5 there, so it will be 15x to the power of 2. So if you try to simplify it, so let me put it somewhere here for the simplification. So the value of your du is equals to 10 multiplied by 3x to the power of 5 plus with 2, this is du over dx, power of 9 multiplied with 15x to the power of 2. So if you try to simplify it, you are going to multiply the value of 10 and also value of 15x squared here. So the value will be 150x to the power of 2, and you are going to rewrite this term again. So you are going to get 3x5 plus with 2 power of 9. So this is the value of your du dx. So we are going to use this number and also again this number and plug in into this formula. So you can say that the final answer for our dy dx is no longer du dx, it is actually dy over dx. You are supposed to get it as 1 over u. So it will be 1 over u here. So the value of your u is 3x to the power of 5 plus with 2 power of 10. Multiply with 150, this one, x power of 2. And you have here 3x power of 5. So you're going to get here 3x power of 5 plus 2 power of 9. So if you try to simplify this one, all this value are gone. So this one you are going to get it into 1. Okay. Then we are going to have the final answer, that is 150 x power of 2 divided by 3x power of 5 plus 2. This is one of the approach that we can use there. Okay, so we have another approach to deal with this one. I will show you after this. But before that, let us try to see on how we deal with the properties of ln. So let's say here you have the properties of natural log. Okay, let's say here the first one, if you have the value of ln a dot b, you can actually change the term into ln a plus with ln b. The second one, if you have ln a over b, you can change the term into ln a minus with ln b. Number 3, if you have ln a where the value of a now is 1, let's say just immediately put here as 1 over b there. So you can change it to ln 1 minus with ln b. And we already know if we try to calculate the ln 1 here, the value will be 0. So therefore you can say that the final answer is supposed to be here negative ln b. This is the third properties. Okay. And the last one here, you are going to deal with ln a power of r there, where r here is belong to the power of a, which is you can write it as r ln a. So we are going to actually can use the properties here to simplify your equation, and then you can start to differentiate. Let us see the same example there. Let's go back to the previous example, number 3, where we are going to use y equals to ln 3x to the power of, if I'm not mistaken, there you have 5 plus with 2 power of 10. Okay, this is the question that we have just now. So basically, for this kind of question, okay, you can deal with the approach number 2 here, where we can apply the properties there. So in this case, we are going to apply the property number 4, which is y equals to ln a power of r. So here you are going to get it as y equals to r ln a. So you can replace, instead of using this function, you can replace into another form here. So in this case, you can say that this is actually our ln value, this is the value of our a, and this is the value of r. This is the value of a. So you can actually get this form. So let us try to convert it into this form, where we are going to get here, the new form will be y equals to 10 ln 3x to the power of 5 plus 2. So then we can start to differentiate. So if we want to differentiate dy dx, the value of 10 here, we are going to copy it again. Okay, copy again the value of 10 here. So you just need to differentiate for the value of ln of 3x power of 5 plus 2. So here you can apply the ln u. So basically the value of your u here, let's try to put it into another calculation here, separate calculation, which is the value of your u here is 3x power of 5 plus 2, and the value of your du dx will be 15x. Okay, am I right? Okay, so here you are going to get the value of your differentiation of this part is equals to 1 over u. So the value of u is 3x power of 5 plus 2, because we have the value of u here, multiplied by 15x. So if you try to simplify it, the value of 10 here will be multiplied by 15x here. So the final answer will be 15x, 150x divided by 3x power of 5 plus 2. So basically, you are going to get the same answer as what you did just now in example 3. So you can stop this video and try to rewind again to see what is your answer of number 3 just now. Okay, so I stop here for the second example, so we are going to see it later in the next video.